In this video, we are going to look at the characteristics of quadratic graphs. This video is going to be for all levels, the IB MYP, the DP and the Cambridge O and A levels. We first start with the shape of all quadratic graphs, which are going to be parabolas. And this parabola can open upwards or open downwards. As we can clearly see in the open upwards graph, as I go upwards, the graph is opening and it's getting wider. Similarly, in the open downwards graph, as I go downwards in the graph, my graph is getting wider. Next, we are going to look at the turning point, which is also called as the vertex. Now, this is a point, meaning it should have an x coordinate and a y coordinate. This is also called as a minimum point if my curve is going to be opening upwards, as you can see in the red curve, or this can be a maximum point if my curve is gonna open downwards, which you can see in the blue curve. And if my question specifically asks about the minimum or the maximum value, I am only supposed to answer the y coordinate of the vertex, because it only determines how high or how low are you on your graph. Moving on, let's look at the axis intercepts. Now, wherever your quadratic graph cuts the x-axis, those points are going to be called as the x-intercepts, which you can see this point and this point. The first point is -1, 0 and the second point is 3, 0. And the point where your graph is going to cut the y-axis is going to be called as the y-intercept, which you can see from the graph as the point 0, -3. Now, it's very easy to calculate these points if you are given the equation of your function. To calculate the x-intercepts, we know that these are points that lie on the x-axis, and throughout the x-axis, I know that my y-coordinate is 0, meaning I just have to plug in y equals to 0 in my function and I will get my x-intercepts. Similarly, the y-intercept is a point which lies on the y-axis, and throughout the y-axis, I know that the x-coordinate is 0. So, in order to find the y-intercept, I simply have to plug in x equals to 0 in my equation and I will find this point. Lastly, we are going to look at the equation of the axis of symmetry, which is also known as the line of symmetry, and it is shown by the orange dotted line on this image. All quadratic curves will definitely have a line of symmetry, and as I stand on this line or as I walk on this line, if I look towards my left and towards my right, I have to see exactly identical graphs, meaning the mirror image of the graph on my left and on my right. Hence, this confirms the definition of the orange line as a line of symmetry, because it divides my quadratic curve into two identical mirror images. The line of symmetry is a vertical line, and it will always be a vertical line for a quadratic graph. And we know that the equation of every vertical line is going to be in the form of x equals to a number. What is going to be this number? This is going to be the number where this vertical line cuts the x-axis. You can also see that this axis of symmetry passes through the vertex. Hence, the axis of symmetry is always going to be equal to the x-coordinate of the vertex, because both have the same x-axis values. Subscribe to the channel and click on the notification icon so you never miss a new video. And do remember to give us a follow on Instagram for more amazing content.